start.
Hey Bob, we've opened it up.
Okay.
Yeah, so people can respond to this question as they join.
Peter, I see it's 10:01. Look to you to decide whenever you or Asia want to kick it off.
Yeah, we have a full agenda today, so I think we should go ahead and get started. So if we can actually go ahead and advance to the next slide, and I will continue to let people in. So good morning, everyone, and welcome to today's information session hosted by CIET on behalf of the ISO's Save on Energy initiative. My name is Peter Lemoine, and I'll be facilitating today's event. First, I'd like to go over a few housekeeping items. I'd like to go over a few housekeeping items. Please first make sure that your microphone is muted unless you are speaking. Second, this session is anticipated to last 90 minutes. Third, we will be monitoring the chat throughout the session for your questions, and we'll address questions that directly pertain to what is being presented. And also, the slides in today's presentation will be shared with you after the session, probably tomorrow. And before we get started with today's session on how to create an energy budget, we'd like to first provide you with an update on Save on Energy programs, and also to let you know about an upcoming survey. And with regards to the Save on Energy program update, I now turn to Asia Staples of the ISO.
Thank you, Peter. Very happy to be here to speak to you all. Just give a few minutes to go over some of our programming, and particularly the Expanded Energy Management Program that launched this year. So this slide provides you with a bit of an overview, if you're not familiar, of some of the industrial and commercial opportunities we have here through Save on Energy. We have downstream, midstream, and upstream incentives. So that includes things like our retrofit program, instant discounts, and our First Nations programs. We also have some performance-based ones, which I'll be talking to you about today. We have the Energy Performance Program and Expanded Energy Management Program, which offers various ways to support your energy efficiency and energy management plans. We also have direct install capability, training and support, as well as market-based ones, such as our Industrial Energy Efficiency Program, which will be a new iteration in the fall. So I just wanted to provide this to you to give you a brief sort of one-stop overview, and I'll provide our website at the end of the slides. So yeah, I'm going to talk to you about Expanded Energy Management Program, which also includes a training and support component, which is why you see the capability building highlighted there. We can go to the next slide, Emily. Thank you. So Expanded Energy Management Program, you'll sometimes hear it referred to as EEM, is for commercial, institutional, and industrial facilities. There are some additional offerings for industrial facilities through the NRCan's Green Industrial Manufacturing Fund that has provided us the ability to offer some energy management information system and the training component for industrial organizations. Some of you may already be familiar or have applied for the program, and for some of you may be new. So I'll just go over briefly the few of the components. Next slide. Thank you. So one of the things I want to highlight is our energy manager support. So there is funding for energy managers for hiring and retention for your facilities with a funding limit of up to $100,000 per facility per year. This is up to 50% of the cost, including training. And what I really want to emphasize here is that until June 30th for industrial facilities, the funding is available for existing employees. So if you are interested, if you think this could support you in your organization, I'll provide the contact information. Please be in touch as soon as possible. We want to make sure everyone who can benefit from that funding is able to. Next slide. Another of the 4 components of EEM is Strategic Energy Management, or referred to as SEM. This is built on our standalone program, which has been very successful. The vast majority of participants are now moving over into EEM. Because of this cohort learning system, you just get conversations and information that are hard to find elsewhere to support you in your energy management. Under this program, the curriculum has been expanded to all fuels, and there are performance incentives up to $100,000. That's at 2 cents kilowatt hour, as well as enabling incentives for things like purchasing equipment for reaching certain milestones of this component. Thanks, Emily. And then there is the Energy Management Information Systems. This is a 2-tiered funding support depending on your gigajoule consumption. Could be up to $50,000 or $250,000 towards the cost of implementation. Whether you're wanting to institute a new system or build on existing systems, this is a pretty great offering through the NRCan funding to support you in implementing those. As these projects sometimes take a long time, I also encourage you to take a look at that if that's something that would support your facilities, and get in touch with us. I'll just mention we didn't have a slide for it, but the capability training, there is free training with this that you can find on our training page. Recently, it's been focused on the energy information systems, if that is something that you're looking at. So you can register your organization at saveonenergy.ca/EEM to get more information or apply. As well, if you're interested in any of our other programs, saveonenergy.ca is where you can find them. You can email us directly at scm@iso.ca, and we have the QR code there at the bottom. If you have your cell phone, we'll take you to the page. And the great thing about the EEM program is it is customized and catered to your specific needs in your facilities. So your first point of contact is an energy coach who will be able to knowledgeably take you through some questions to see what your needs are and how the program can help you. So thank you, everyone. Thank you, Peter, for the time.
Well, thank you, Asia, for that update on Save On Energy programs. And the last thing before we get started, I just wanted to let you know that you'll be receiving an email to provide that will have a link where you can provide feedback on this training. The email will come from surveyinfo@forumresearch.com. And like I said before, we'll also be sending you this presentation after the event. So you'll have this information on the email, and you'll check your spam folder just in case it gets sent there. But without further ado, I'd like to go ahead and introduce today's presenters and get started. We have Emily Thorne-Corthay and Robert Story of Thorne Associates to lead today's session on how to create an energy budget. Thorne Associates is a reputable consulting firm known for its expertise in sustainable energy solutions and environmental consulting. They specialize in advising businesses and organizations on implementing sustainable practices, optimizing energy use, and navigating regulatory frameworks related to environmental compliance. They are recognized for their comprehensive approach, blending technical expertise with strategic insights to help clients achieve their sustainability goals. Their team comprises seasoned professionals with backgrounds in engineering, environmental science, and policy. Thorne Associates works with clients across various sectors, from commercial to industrial and institutional entities. So welcome, Emily and Bob. And with that, I turn it over to you to take us through the session.
Thank you so much, Peter and Asia, and really excited to be here and discuss energy budgets with all of you. I think we have a good number of participants, and nice to see such an interest in this topic. So today, the main objective is basically to help you understand the purpose of an energy budget and how to develop one. And if you already have developed, energy budgets yourself, then hopefully also to help you improve upon your existing techniques. There are some specific objectives that we're also hoping you will achieve in turn, including understanding the process for creating an energy model based on an analysis. This is not going to be an in-depth, energy modeling training. It's a 90-minute session, as Peter said, so it'll give you at least a brief overview of energy modeling, and then we would encourage you to look at some of the other training courses available on in-depth energy modeling. It will also help you to become familiar with particular opportunities and challenges for Ontario facilities, such as global adjustment and market renewal. And I do know we have a number of participants who are from not only Ontario, but also other provinces and even from the States and internationally. So if you are not from Ontario, then, I think the vast majority of this content will be relevant, but we do have some Ontario specific content as well. And then identifying strategies for making assumptions to address uncertainty, with these tariff situations. I think uncertainty is the word that is on all of our minds these days. So whatever can be done to help with energy budgeting, then that is certainly, I think, quite important. We do have a case study on a large mine and mill that we will be going through, and towards the end of the session, Peter will be putting into the chat. We do actually have a more sort of complete version of that case study that we'll be presenting high level and that you'll be able to access from the ISO's website. And because this is a peer learning session, we are hoping that you will share experiences and tips with your peers. So if you do want to jump in, at any point, sort of time permitting, so I guess at the beginning I'll see, how much interest there is, but if you would like to, bring some of your experience, you don't have to necessarily wait to the end, and we'll go from there. Okay, so most importantly to start, why develop an energy budget? Well, first of all, in industry, especially heavy industry, energy is often the largest cost after labor, right? So here we have kind of the second to fourth highest operating cost. And with our clients who are usually heavy industry, we typically see it as second or possibly third. So it's a very big cost in your operating budget, and very important to manage. It's sometimes pretty astonishing to have. Sometimes we see clients with over $1 million in energy spend, and if you had a machine, anyways, I think in terms of managing that, it's kind of surprising that sometimes companies do not have energy managers if they're spending over $1 million on energy. So having an energy budget is going to be a really important part of that energy management. Having an energy budget also helps stakeholders understand your energy usage and costs under various business and operating conditions. So you can make, different scenarios of energy budgets, and that'll help sort of on almost like a sensitivity analysis. We do use software, and we'll give you some examples of various different energy modeling software that can be used to help make that sort of scenario analysis easier. Energy budgets is a crucial element of a management reporting system. So your executives are going to, again, want to understand the costs, the forecasted costs. Often energy costs rise, faster than inflation, at least here in Ontario. That's definitely been the case often in the recent past and in the future. And so understanding those costs and how they're projected to go forward is going to be important for executives. And there's a little rule of thumb: if it's important to my boss, it's important to me, right? So I think that's a good little saying to keep in mind. Actual energy consumption and costs should be reported against the budget on a monthly basis at a minimum. And then you don't just want to stop there, right? Your energy budget should not be static. Ideally, you want to, have timely management reviews, corrective action, and budget revisions as necessary as things change. And if you have, high energy intensity, like highly energy intensive operations, you may want to do it more often than every month. So weekly, daily, in some cases, maybe even hourly. Okay, so let's dive in now on the steps to creating an energy budget. So there are 3 main steps. 1, build an energy model for your facility. 2, and the energy model, by the way, will be using historical data. So will be all that sort of historical data collection will be part of that building of the energy model. Step 2 is collecting operational forecast data on factors that influence energy consumption. So looking at, we'll get into that in a minute, what are called independent variables, such as, your production forecasts, weather forecasts, those kind of thing, and as well as forecasted utility costs. If you don't know where to get those, there are a number of industry associations and energy consultants who do have forecasted utilities. Here in Ontario, Market Renewal for Electricity is making that a little more challenging these days. Also more opportunity, I think, for increase in profitability or loss, depending on how you do that. But certainly I know, for example, the Association of Major Power Consumers of Ontario provides electricity forecasts for those who are members and other energy consultants. And then the step 3 is entering those forecasts into the model to estimate your energy budget. So we are going to dive in a lot more detail now to these 3 steps. So the first one, we're actually breaking down into 6 steps now. So to build an energy model, first of all, for those who are not familiar with energy modeling, we'll just provide a brief introduction. Then we're going to go through how to collect historical energy data, as well as collecting data on independent variables. Again, we'll define that in a minute, but essentially that's, weather, occupancy, production, sort of non-energy variables in this case. Then maybe the most core component of this model is the analysis phase, and we'll go through some different analysis techniques that you can use. And then once you've got your model, you'll want to review it and make adjustments, make sure it's, statistically significant, et cetera. And over time, as your facility changes, if you've got new, production lines, new product mixes, that kind of thing, then you'll want to update and improve your model. Okay, so let's start with the introduction. Just as a note, the focus of today's training will be on electricity with a small portion as well on natural gas. Of course, many of your facilities will use other fuels such as diesel, propane, and if you're in steel, you have so many. We've done some work in steel for sure, and the coke oven, gas blast furnace, gas, BOF gas, etc. So you could have many different fuels. We just are going to be focusing on these two, primary electricity, but I would say the concepts are going to be the same, right? And you're going to want to model each energy source typically independently, at least at first. And so this will apply to all fuels. So a good model is a powerful tool to help understand how your facility uses energy over time and also understand changing conditions. You do need to develop a statistically valid model. And again, we'll go through some statistics techniques on that. Don't get scared if you're not an engineer. To do a simple energy model, you can use simple high school math. There are some more sophisticated modeling techniques that do require more advanced university level mathematics, etc. But to start, you can certainly do that and do not need to be an engineer. There are published standards, guidelines, and certifications in the field of energy modeling. So again, this is just a short introduction. And if you do want to do significant energy modeling, we would refer you to dive deeper into some of those. And there are also some various incentive programs that have specific requirements for models and for reporting. So it is very important to understand those requirements before trying to apply and receive those incentives. And I did want to say, with modeling, garbage in is equal to garbage out. So we'll talk a little bit about the data collection piece, but it's really important that do proper data cleaning. At Thorne Associates, we have some work on artificial intelligence and certainly having good data visualization and understanding the proper data cleaning procedures at the beginning, removing negative values where they make no sense, etc. is really important. And I'm guessing some of you work in measurement and verification of energy savings, and so often energy models are needed to do your job, and especially if you're looking at the International Performance Measurement and Verification Protocol, which is sort of the key resource, and option D is called calibrated simulation, and you definitely will need an energy model for that. And for those of you who don't think you do energy modeling, if you are making a simple energy budget already, you are likely doing some form, albeit maybe very simplistic, maybe just assuming like flat line and the same every year, but that is a very simplistic model, but so you're probably doing some already. So just continuing along with the energy modeling here. So it's used to simulate, analyze, and predict energy consumption in any type of facility, process, or vehicle using statistical methods and visualizations. And you require for an energy model two things. You're going to need independent variable data. And an independent variable are those that are independent of other variables in the model. So, outdoor air temperature is not going to depend on your production volume, and your occupancy is also not going to depend on your, well, I was going to say your occupancy does not depend typically on your outdoor air temperatures. My girls only have 8 people in their class today, so I think the heat wave we're having in Toronto is actually affecting occupancy. But typically, you would not see that, I guess, relationship, right? So where you have independent of other variables in the model, then those are necessary to input. And then you have dependent variable data. In our case, because we're building energy models, the dependent variables are those that are dependent on the independent variables. So energy use is going to be dependent on production volumes, on occupancy, on outdoor air temperatures. So, and again, we would suggest you should model electricity and gas separately. So here we have a simple model showing energy consumption here on the vertical axis and production here on the x-axis. The graph you can see is a straight line relationship between the energy and production, meaning that as production, you can see as production increases, your energy consumption is also increases. And I think another thing you should note is look at this collection around the zero value here on the y-axis. So what this is telling us is that, yes, there are some 0, which actually doesn't occur very often. That's a very complete full shutdown. But what you're showing here is some base load. So when there's no production, you're still going to have some energy, right? You're going to have lighting, maybe office energy use, HVAC that's independent of production, and understanding if your base load, if you do not already have a good understanding of what your base load is, that would be a very important first step, because trying to reduce your base load in an industrial facility is an excellent way to reduce your energy costs and your energy budget. And just to sort of caveat, inaccurate or misleading energy models can lead to significant financial implications for facility owners, incentive programs, and other stakeholders. So there are several recognized authorities, such as ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, Caltrac, and the IPMVP I mentioned before, on the statistical requirements that are needed for data used to assess your facility energy performance. And the ISO, the Energy Performance Program that Asia referenced earlier, does have some requirements on acceptable data testing methods as well, and you can look at the ISO's Energy Performance Program for more detail. I'm just going to pause here. We've finished the intro to energy modeling. We'll go through into data collection in a second. But to my colleague Bob, do you have anything to add? And or Peter, are there any questions in the chat?
Yeah, I just wanted to mention on the chart, so we're showing a straight line, and in almost every case, a straight line model is, you're going to be able to find a straight line model, or that's generally what you're going to be using. There are cases where it might not be a straight line. That gets into sort of more exotic modeling, but and there are facilities that where you can use like a parabolic curve or something even more sophisticated. Generally, and again, that's sort of more sophisticated modeling, but by and large, a straight line model should be adequate for energy modeling purposes.
Thank you, Bob. And Peter, was there any questions in the chat?
Yeah, we have a couple of questions. First, there's a question from Allison with regarding the granularity of the data. So for the model, is daily data preferred if possible?
Yeah, so great question, Allison. So I would say it's best to start with monthly, because that's less onerous, et cetera, and see what kind of relationship you get, right? We're going to talk in a minute about the R² value and what that represents, but essentially it represents how well does the model represent the data. And if you already have a really good R² value, then I would argue you don't really need to go to daily unless there's some sort of specific aspect that you're trying to get more detail into, or if there's some piece of equipment that has very significant variations within the day that's not kind of running constantly that you want to look into further, you can use some sub-metering on that specific equipment and then use daily or even hourly in that case. But I wouldn't start with that. I would start with monthly, see what you get, and then go to daily only if needed. Bob, any thoughts that you want to add?
Yeah, I would completely agree with that. There's a huge difference in just the volume of data you're going to be handling. Daily, I typically look at when I'm having trouble with the monthly numbers and I want to understand what the differences are. I think I saw somebody in the group that was from an asphalt plant, and I remember doing a lot of work with that industry and finding out the impact of like rainfall and humidity on the operations. And sometimes, they would have to run much longer one day just to take advantage of good weather and, that type of thing. So looking at daily or in some cases even hourly data is great to help understand fluctuations. But if you can get a model monthly, it does save you managing much larger amounts of data in your model.
Thank you, Emily and Bob. Just one more question, then I think we can move on. Tony asks, can you share some sources, if possible, free, where you can get weather forecasts and utility cost forecasts?
Yeah, so I'll start and maybe Bob, you can add. So weather forecasts, like Environment Canada is a good source. And I know when we were building an energy management information system, this was a few years ago, but the software engineers were able to actually, use what are called APIs, application program interface. It's a software term to hook in directly to Environment Canada and get some of those weather data. So I'd say from a weather perspective, that's probably the best. In terms of utility forecasts, as I mentioned, I know the Association of Major Power Consumers of Ontario, but that's not that's free if you're a member. If you're not a member, I'm not quite sure if the ISO does publish long-term, because usually when you're doing energy budgets, it's beyond just 12 months. At the minimum, you would want to do 12 months, but Bob, do you have any insight if, and again, we use also other energy consultants, but that's also paid data. So yeah, but we get the access through those. For example, Thorne Associates is a member of the Ontario Mining Association, and through that membership industry association, we get access to these utility price forecasts from other specialist energy consultants. So I would encourage you to become a member of your industry association and look, Canadian Steel Producers Association, they may have access to those kind of work, or automotive association as well. Bob, anything you wanted to add?
Yeah, I think I agree with all those sources. Certainly, ISO is going to be sort of your first point, but then if you're looking at anything sort of longer term, or again, also for those of you working with a local distribution company, which would be most of you, look to them to help as well. I spent several years working with Toronto Hydro, and we were certainly a very good source of that type of information to help do some extra research or whatever for customers who required it. So look to your LDC. That's generally going to be free, or they might have other local consultants who they can recommend as well.
Great, thanks, Bob. Okay, I think we'll move on then for now, just in the interest of time, and we'll pause again for questions in a little bit. Okay, so we finished the intro on energy modeling. Now we're going to get into the first sort of real step, which is collecting your data. And so we'll be talking about collecting both historical energy data and then also talking about historical independent variable data. So historical energy data, again, usually monthly consumption and cost data are sufficient, at least initially. This is actually kind of answering the question earlier, but daily data can provide more accurate when needed. And again, starting simple and then diving down to the complex, I think that's a good sort of rule of thumb or framework so that applies not only to the consumption and cost data in terms of the frequency of start with monthly versus daily, but also in terms of the accuracy. So start with the main utility meter, see what kind of relationships you get. And then for larger, more complex facilities, you're going to need submetering data. So a submeter, if you're not familiar with that term, and that can be an electric, gas, or water submeter, it's used within a building or facility to measure the amount of energy for a specific process or specific piece of equipment that's smaller than the whole facility. And you can install a permanent submeter, or you can have temporary or portable submeters that are going to log your energy consumption for those, again, specific processes or equipment. Now, again, for our clients, they're almost all, at least medium size or larger and quite complex, heavy industry. So we will always be using some submetering data typically, but again, start with utility if you might be lucky if you have a simpler case. And we even actually often deal with annual data if we're dealing with a client and they want a budget forecast for 15 years in the future, then we actually will go to annual often to start, because they won't have some data monthly for that. Bob, did you want to say something?
Yeah, I just want to mention with submetering, I've seen a number of situations where a larger facility may actually already have utility submeters as well, either just legacy meters, or there may be other utility meters in your facility that you don't see in your bills. They just get totalized and you get one big bill with all the meter data. It's generally available if, again, your local distribution company can give you the underlying data from their submeters that are in your facility. It's not unusual to see that at all.
Thanks, Bob. Okay, so when you do your data collection, it's important to understand, where the sources of the data are and how you're going to retrieve them. So most utilities provide what are called interval meters for industrial customers. So an interval meter, again, it can be electric, gas, or I guess even water. I haven't seen water, but anyways, to measure and essentially transmit or record consumption over certain periods of time to enable time of use billing and demand profiling. They're also called smart meters. So basically everybody hopefully has moved to interval meters at this time, although maybe not all, but it's certainly becoming industry standard. And often energy data from those utilities can be accessed through what's called a green button service. Now this would be more, I think, of the Ontario specific. So if you're international, you probably do not have access to this, but the green button is an idea of just, you have one button to press and you can get all your data. So it's supposed to be much easier. And for your submetering data, that if you own those submeters, which is, I would say, typically the case, then you can get those if you have an energy management information system. And you may need to do some manual data entry, but I would suggest if you have to do it initially, try and work towards minimizing that as much as possible. Okay, so we talked about historical energy data. We also need to collect historical data on independent variables. So this could include, as I mentioned, production or facility volumes by category. Again, daily if possible, but I wouldn't start with that. Operating hours is really important. Occupancy levels, if that is relevant for you. Number of events held, again, if relevant for you. Outdoor temperatures is almost always relevant, especially in unconditioned spaces. Often industrial facilities are either like only minimally heated. If you have lots of furnaces and mills and this kind of thing that are generating lots of heat, then often there'll just be some small amounts of heaters. So anyways, outdoor air temperature is important. Hours of daylight may or may not be relevant, and any other environmental data. Recall that the independent variables are the ones that are not influenced or independent of the other variables. Okay, so once you have collected your historical data, including your energy data, the dependent variable and your independent variables, such as production and weather, the next step is to use some type of software to do the analysis step, which again, I mentioned the analysis step is arguably the most important. So I wouldn't, knock Excel spreadsheets. They do, of course, have limitations, but we do a lot of custom modeling, and we actually use the energy budgets for our customers is actually almost a starting point for a whole decarbonization target model. So when we're developing a whole decarbonization plan, say out to 2030, for example, then we start with collecting the historical data, then we get the forecasted data, we develop, and then we have all the costing as well. So we have now energy budgets forecasted out 10, 15 years, and then we identify decarbonization opportunities and actually use, again, leveraging that sort of energy budget data to then develop whole decarbonization costed pathways and help our clients choose which is the most cost effective for them to achieve a greenhouse gas reduction target. So energy budgeting can be just, I would say, the foundation to even building further in terms of your goals of energy efficiency, reducing energy costs, and decarbonization. There are other excellent software. For example, that RETScreen is low-cost specialty software developed by CanMet Energy from Natural Resources Canada. And this is available internationally as well, by the way. RETScreen Expert is a great, there's lots of training for that, and I would say has been recognized worldwide as an excellent software. And then there's some other energy management software that can be combined with other data tools to provide some additional data at the process level. Our clients, for example, often use OSI SoftPi as a data historian that is pulled in and can be combined with their energy management system, like Schneider Electric's EcoStruxure or others. I'm just putting, not recommending any of these, but just to help you understand what's out in the market. Some other examples, of energy modeling software. There's the US government has the Energy Plus software, and previously eQuest and the Canadian version CanQuest were used extensively. They unfortunately are no longer supported, so they're being used less extensively now. And continuing along with the analysis, and Bob, I'll probably pause at the end of the analysis section for you to add in anything. So once you've decided which software you want to use, then one of the first steps in data analysis is to do data visualization. And when you plot the data, aka visualize the data, then you can see the distribution of the data points. So you might want to use scatter plots or bar charts to help you sort of see the factors and those relationships between independent and dependent variables. And we are using statistics here, right? So statistical techniques to mathematically solve or describe the relationships between the independent and dependent variables. And some of these statistical tools can be preloaded or downloadable on spreadsheet software, such as Microsoft Excel. But again, specialty software such as RETScreen can offer additional optimization. So let's look a bit further into the analysis piece. Again, arguably the most important. So we sort of already talked about using daily or monthly energy consumption for each source independently. Modeled in isolation, we talked about that. So some process can be modeled effectively just having one dependent, the energy variable you're kind of looking at, and the independent variable such as production, but others need two or more independent variables to get a good statistical correlation. So for example, natural gas, we find if natural gas is used mainly just for heating, then you can often get some really excellent statistical correlations between heating degree days and your natural gas use. And that's just one, the independent variable is your heating degree days, and that's just one variable. And you can get some, I would say even in the 0.9 of the R squared, which again, if you don't know what that means, we'll get to that definition in just a minute. And then electricity, however, we do typically see needing two or more independent variables. So having, both production and outdoor air temperature or heating degree days and production relating to electricity, for example. Okay, so we're going to go over the most common analysis techniques now. The most common technique in energy modeling is regression analysis. Now, regression may sound like a fancy name, but it's just what you learned in elementary school. So y equals mx plus b. And we'll get into that on the next slide on what that means. Usually you want to try and have at least 24 months of historical data because you're going to want to ideally have, at least 12 months of baseline data. So if you have 24, then you can kind of choose the best 12-month period that's the most representative of your facility's use. And if you have just one independent variable, it's a simple linear regression, such as the one we showed you before on just production and energy. If you have two or more variables, it's called multiple linear regression, or I usually see it as like multilinear regression. And so when you do a regression analysis, there's two main outputs. So you'll have a best fit line equation. This is this y equals mx plus b. And so just recall that m is the slope of the line and b is the y-intercept. The coefficient of determination is kind of, again, the fancy name for everybody usually just refers to it as the R-squared value. And when you use an Excel and you just, if you have a graph and you just right click, you can show to display both the best fit line and the R-squared value. So it'll just tell you right away from that. So it's a measure of the statistical validity that explains how well the independent variables explain the variance in the dependent variable. So AKA, how does the production explain the variance in the energy consumption? So another way to say that is how well the equation fits the data. So in terms of R-squared, the values do vary from 0 to 1. 0 is no variance, so like no correlation. So that's a terrible model if you get near 0. If you have 1, I would say there's a problem because that's a perfect correlation and that's theoretical. So I've never seen a model that has 1. So I would also say if you get that, that's a problem. You want to be somewhere in between. Ideally, you want to be at an R-squared of over 0.75, which means that 75% of the variance in the data is explained by the independent variables. So AKA that 75% of the variance in the energy, the changes in the energy, can be explained by the production, for example. And that would be when using at least 12 months of historical data. So you want to get an R-squared. If you get an R-squared of 0.75 on 1 month, that's usually not sufficient. And that equation in the form of y equals mx plus b is called the baseline equation. And that is the baseline equation of the model and will be used to predict future performance. So here you see an example of a baseline equation. So you have the graph with the kilowatt hours in this case on the y-axis and the heating degree days, which is a proxy for heating like temperature essentially, on the x-axis, and you have your equation again, just right click in Excel. You can get this of a trend line of this y equation, and you see an R-squared value of 0.98 essentially, which is very high. That's relatively unusual, but is, I guess, potentially possible. I usually only see that with natural gas. And to wrap up on the analysis, and then I'll pause for some questions and comments. The baseline equation is a foundation of the energy model. So again, just going back, so I'll just go back one slide. When we talk about baseline, so it would be this y equals 10.9x plus 320 essentially would be that baseline equation. And that should be your key kind of output along with the R-squared value. So it's the foundation of the energy model, and it's used to explain both historical behavior and predict future performance. And I would say big star in the absence of interventions or unusual conditions. So the baseline equation is only going to do your predictions accurately if you have not made any major changes, right? It depends on that. It'll forecast sort of in context of what the historical conditions would be. Just want to mention a few statistical techniques. So in addition to the regression analysis that we talked about, so there is something that has a very big name called coefficient of variation of root mean squared error. So I'll try and just break that down for you briefly. So root mean squared error, or RMSE, is a commonly used metric to assess the difference between the predicted and the actual values in the model. And it quantifies the average magnitude of the error, but it's sensitive to the scale of the target variable. So that's why we add in the CV, the coefficient of variation, which basically divides the RMSE by the mean of the target variable. And so what this indicates is if you have a lower CV RMSE, it indicates the model's predictions are closer to the actual values and relative to the mean of the target variable. So a CV of 25% or less is often considered acceptable for building energy models. So again, I think the takeaway is you want to minimize the error, right? And you want to have a CV RMSE as low as possible, under 25%. Next, we have the net determination bias error. So this is another statistical metric that quantifies the systemic error or bias in a model's predictions, and specifically how much it over or underestimates compared to actual values. So basically it's checking if the model is consistently too high or consistently too low in its estimations. So a good model should have a net determination bias error as close to 0 as possible, indicating minimum bias. And then lastly here is this T statistic, or it's known as T-stat. And these evaluate the likelihood that an observed difference between the sample data and what's called a null hypothesis, or between two samples, are due to random chance or real effect. And here what you're just trying to say is like the sample of data that you have compared to the larger sample size and the variation, is it just random, or is there like a real effect going on? So you want of the value to be a large absolute value in terms of your T-stat to be saying that yes, there's actually some kind of real effect here going on between the independent variables and the dependent variables, not just sort of random chance between the sample size. And then just lastly here on this bullet point, ISO 50001 series, which is of course the energy management series, the IPMVP, which we talked about previously, and others provide some additional technical guidance to develop and analyze energy models and baselines, but they do not specify a minimum R². So that was a lot on the analysis. Bob, do you want to add in some context or comment?
just some points. We provided this amount of detail just to to explain sort of what goes on and to give an appreciation that there is a lot of kind of checks and balances in developing a model. But the good news is that if you're using tools like RetScreen, a lot of these capabilities are already built in. Like just entering your data, RetScreen can sort of take care of a lot of the analysis for you, or indicate any errors or flags. And also, if you're in Ontario and you're participating in the Energy Performance Program, the ISO's program, there are in the early stages of that program, you had to kind of provide all your charts and analysis and sort of explain yourself. The newer iterations of the program provide, if you want to use them, preloaded charts and tables where you can simply enter your data, and the statistics will kind of be tested automatically. So and the models can tell you whether your data is clean enough to participate in the program or not, and it can can save you a lot of work right away. That it's you can, if you would like, you can go further with your data, but it meets the criteria of the program.
Thanks so much, Bob. Peter, any questions or I did see one thing I just wanted to address. Someone made a comment about electricity use should be normalized with heating degree day and cooling degree day both. So I guess in Ontario, in my experience, very few industrial facilities will have air conditioning. So really, at least in the offices, yes, but that's often a really minor percentage of overall energy use. So yes, as a best practice, if you are having significant amounts of cooling, definitely if you're doing any kind of refrigeration, or if you're in the like food industry and that kind of thing, then you may have some significant cooling. But yeah, so I just wanted to address that. That was in the context. If you have no air conditioning, then your cooling will not be so relevant. Peter? Oh yeah, Mike or Bob?
Oh yeah, I've seen a couple of plants that did have kind of a seasonal, a significant seasonal difference, where you actually did have to break maybe into two models. You had sort of a cold weather model and a warm weather model. We'll talk about that a bit later, but it's not unheard of to have a model that's less than a year, just because that's the way your equipment performs. So you could have, like this was a plastics plant that using example, they had very significant cooling, refrigeration type loads, but in the colder season, and this was partly just because of the way they ran the facility, it was quite cold. They didn't use a lot of natural gas for some reason, and they were essentially heating their plant with their equipment. So in the winter, there was some very strong correlation to cold outdoor air temperature or heating degree days. But then as it got warmer outside, then was dominated by cooling degree days. So they had sort of two models that worked for that plant that were both less than 12 months.
Thanks, Bob. Peter, anything from the chat?
Yes, I think we'll focus on one question now. Reza is asking about Excel models. And so could you explain maybe what a simple Excel model might look like?
Sure, yeah. So, a simple Excel, we can just use those regression analysis literally. So you can pull in again, historical energy data. So you'll have, your column you'll have every month, and you'll have your column of your energy or your electricity. For example, you might have separately, you'll have your natural gas. Then you'll have like column you'll pull in your production data, you might pull in your outdoor weather, and then literally you just go to Excel and do the graphing again for the data visualization of plotting. Again, you might start with just a simple linear single linear regression where you just plot production and electricity. You right click on the trend line, and that'll give you your R squared and your baseline equation. See if it's good enough. If it's not good enough, try and do the multi-linear where you'll just select multiple of those independent variables. So again, maybe production and occupancy, for example, versus electricity, and try and get a good R squared. So at the very simplest, that would be a simple Excel model, I would say.
Yeah, I just like to add, if I don't know if the person asking the question was in Canada, but I would expect probably a good number of people on the webinar today have probably participated in a dollars to cents workshop, probably with Stephen Dixon. Hopefully, he's a great presenter. I know Stephen used to provide sort of customized Excel templates in those sessions that were really, for most purposes, quite good enough. I mean, I generally use those rather than RedScreen because they're very quick to use, and they were free of charge for all our participants. But also it's also with Excel, I haven't tried this. I don't know if it works on the sort of very latest versions of Excel, but you may need to download through Excel an upgrade pack, a data analysis pack. It might not be preloaded in Excel. You might need to download the two, which are free through say Microsoft. There is an add-on, I believe they call it, that you might have to add to get access to some of the analysis tools.
Great. Okay, thanks, Peter. I think we're going to keep moving just from
Yes.
yeah. Okay, so once you've completed your analysis of your model with the historical data, you should review the model and make any necessary adjustments. So, if you added a new production line, for example, you'd need to adjust the model. In 2020, due to COVID, if you had, models before that, you're going to need to adjust for the situation of lots of shutdowns. Also would not recommend 2020 being a base year because of the significant amount of shutdowns. So again, you want to review the models with your team to see if any events have recently influenced energy consumption, adjust for any of those unusual events or production changes. You may need to modify or remove unusual periods from the baseline to develop a useful model, but be careful if you do, they should be identified and documented, and make sure all of your assumptions and calculations are visible, easily located and transparent, especially if you're doing external reporting. The assumptions and the sources of data is extremely important to be stated. I would say not just for external reporting, but for, again, your boss. I do a lot of quality assurance of all the technical calculations that my team does, and I really insist all assumptions and all data sources have to be stated, because if ever someone comes back and a client asks where that came from, you need to be able to justify that. And then finally, for the model portion, you do want to do some updates and improvements over time. So you're going to want to adjust if you have significant product mix changes, throughput, occupancy, major process redesign, major facility changes, or significant fuel switching. So now we've completed all the steps to create an energy model, but recall, using historical data to create the energy model is actually just one of 3 steps to create an energy budget. So we finished step 1, creating the energy model. Now we're going to talk about step 2, collecting forecast data, and step 3, entering the forecasts into the model to estimate the energy budget. And we're actually going to be basically combining sort of steps 2 and 3 by discussing collecting forecasting data and using the energy model and forecasting data to create your energy budget. So to develop your energy budget, we're going to go through the overall energy budgeting process, again, based on that the model is now complete, talking about data collection and entry for the energy budget portion now, analysis of your energy budget, and quality control and validation. So within this, we're going to be talking about entering your forecasted independent variable data into the model, which so similarly, we did the historical, now we're doing the forecast, right? So the forecasted production, forecasted weather, et cetera, forecasted utility, analyzing forecasted energy consumption by energy type, and then also forecasted commodity price data. So commodity pricing, meaning like the hourly Ontario electricity price, for example, and associated pricing factors. So as you may know, electricity is not just one value, but typically there's what we call the commodity pricing, which now actually with market renewal, it's no longer called the hourly Ontario electricity price as of May 1st. It's called the simplest version is just called the Ontario price, but then there's demand charges as well, and global adjustments that need to be added in there. And then you have to combine all the forecasts above into tables and documents to get the budget. Okay, so we're going to sort of discuss where you can find this forecast data, how to make sure it's good quality, etc. So data collection and entry for the energy budget now, you're going to want business data, you're going to want electricity price data and natural gas price data. And again, if you use significant amounts of other fuels such as diesel or others, you should definitely add those as well. So business data would be, again, forecasted production rates, forecasted product mixes, those kind of things. Labor, perhaps, if that's relevant. So you collect those forecast data from internal sources. So usually, your finance team would have a lot of that data. They are going to need to forecast that. And I would really suggest, sometimes we see huge disconnects between energy managers and operations and finance. And so the budgets, the energy budgets are sometimes really way off, to be honest, like vastly incorrect in terms of forecasting, because the finance people are disconnected from the reality. So I think it's actually an energy manager's job, and I think many of you are energy managers, to be that bridge between operations and finance to make sure that these energy budgets are accurate, because they're really important. Again, if you're in heavy industry, you're going to be maybe energy being the second most important operating cost after labor. So it's really important to get this right. So the accuracy and usefulness of the energy budget is directly proportional to the accuracy of the business forecast, right? So if there's a lot of uncertainty, you may need to develop multiple versions to address different forecast scenarios. So, acquisitions, for example, or divestments of different, if you're looking at a whole, global organization, that's going to be really important, maybe to forecast some different scenarios. If, depending on what is being, if you're acquiring, multiple facilities and divesting from others, that'll be important to consider. And then if the forecasted product mixes and volumes are within historic ranges, then your energy model should do a pretty good job of working, right? But if it seems wrong, it probably is. So go with your gut and start investigating further. We've had many times where we've been provided with different forecasts from different clients, and we've kind of pushed back by stating, based on our experience, that this doesn't make sense for X reason or Y reason. And so, and then we've got them to actually correct their forecast, and for, again, for the whole company in the budget. So this doesn't happen like it's not rare. I would say it's actually quite often that the budgets are perhaps done too simplistically and are not considering enough factors. And so as consultants, again, we often sort of help push back and get those to be a bit more accurate, which is really important. So yeah, for example, if you have a 50% production increase above historical values by perhaps adding a night shift or adding significant non-production heating, like HVAC loads or lighting loads when the building was normally vacant, those would be things that you'd have to adjust your model for. In terms of electricity price data, so as I mentioned, there's a variety of different factors. There's sort of a fixed monthly cost for your customer account charges. And then there are these commodity charges, which again are now called Ontario prices or Ontario energy prices. No, yeah, Ontario prices. Global adjustment is a demand-based charge. If you don't know, if you're in Ontario, that is in Ontario only. For those outside of Ontario, don't worry about this, but you probably have in your province or state a demand related charge, so a kilowatt basis, versus your commodity charges are on a kilowatt hour basis. So you can see here, the first part here is a rate at per kilowatt hour. And then here you have a per kilowatt. So those are your demand based charges, including transmission and distribution. And then there's also some regulatory charges, which are often on a per kilowatt hour basis. There's also power factor, where it's beyond the scope of this course today to go through these, but there's a number of other charges that are going to be in your electricity bill and that you'll want to include and make sure you model. So when we do energy modeling, we actually will look separately at the commodity charge versus the global adjustment charge. And then we often just have other charges that we'll group together if they're not too significant, which they're usually not, and neither do that on a fixed basis or maybe on a per kilowatt hour basis. But we definitely do model global adjustment or that big demand basis compared to the per kilowatt hour or commodity charge separately. And then when we do if you're doing, energy efficiency projects or decarbonization projects, when we model those, we make sure to separate out again the global adjustment and the Ontario price per kilowatt hour charge separately to get accurate costing of how in fact those are going to actually reduce costs in your future energy budgets. And that's quite important. There does get to be some fairly complex situations here. Speaking of complex, the new kid on the block here is market renewal as of May 1st in Ontario. And there are some other jurisdictions that have a new market similar to this. So Ontario's method for calculating the wholesale commodity electricity market portion of the electricity price has now changed. So it used to be the HOEP or hourly Ontario electricity price, and now it's just the Ontario price, or if you're a bit more sophisticated, you might have chosen to use a locational market price, or if you're a generator, I don't think there are any generators of electricity on the call, but if you are, then I believe you must use a locational market price. So this market renewal, we're not going to, people have been working on this for a decade plus. It's a once in a generation kind of major opportunity here to save money for Ontarians and make the wholesale electricity market more efficient. So I'm not going to go into many details, but just really basically what it is, it has three main components: a new day ahead market where you can know with certainty what the pricing is going to be a day ahead. There's a new price responsive load option in addition to the traditional dispatchable and non-dispatchable load options. Loads are, the customers who are consuming, so that's probably pretty much all of you. And a new location-based commodity pricing for generators and some typically large electricity consumers, which is that locational market price, which you can subscribe to. You can choose to basically do that. Just some other, the rest of the points, that was the main point for market renewal. The others are kind of more generic electricity commodity related pricing. So customers are charged at the applicable commodity price. That's usually basically the average kilowatt consumption in the same hour multiplied by that price. So your interval meter will show you an average kilowatt in 1 hour. Then you multiply it by now the Ontario price, or in dollar per kilowatt hour, to get your commodity charge. If you can time shift your use, there can be some significant benefits. Yeah, the ISO does provide that forecast of commodity prices, although again, I'm not sure for how many years in the future. Certainly, they definitely do short term. So for a shorter budget, that'll work, but you'll likely want to get longer term as well. And then you can purchase electricity at contract rates, fixed or variable, in lieu of market prices from a third party, but you still pay the global adjustment. So just do be careful. A number of years ago, when the global adjustment was introduced, there were a lot of very, very angry people who lost a lot of money because they didn't realize that they still paid the global adjustment, and they had a very bad situation. So if you do that, just make sure that you understand all the implications. I think I'm just going to keep going and then I'll, in a couple slides, let we jump in for any questions or comments. So global adjustment. So all customers in Ontario pay the global adjustment that covers the base costs for running the electricity system, including new infrastructure, regulated rates to suppliers under contract, and energy efficiency programs. So there is two types of customers in Ontario. There's the Class A and the Class B customers. So Class A, who participate in what's called the Industrial Conservation Initiative. I believe you have to have over 500 kilowatts, like half a megawatt of demand. They basically, their share of the global adjustment is determined by taking Ontario's top 5 peak demand hours. By the way, it looks like yesterday will be one of those hours, probably around 7 p.m. And possibly today. And they're looking at their share of those hours. So if a Class A customer accounted for an average of 2% of Ontario's peak demand during those specific hours, they'll be paid for 2% of the province's overall total global adjustment costs. And the global adjustment is typically driven by hot weather in Southern Ontario and all of us turning up our air conditioning. So in terms of electricity price data resources for your budget, because you're going to, again, need to get this forecasting, there's some resources here. And again, you'll get a copy of these slides, and these are active links. So you'll be able to look the Ontario Energy Board, Understanding Your Electricity Bill, ISO's Electricity Pricing Explained, the ISO's HOEP and GA Forecast Peak Tractor. Peak Tractor is specifically for the GA. Your local distribution companies like Toronto Hydro, there's an interval meter sample bill that you can look at, and of course, specialized energy consultants. This is the peak tracker from last year, ending March 31st, 2025, and we've already blown through, we're already higher. Yesterday, we were close to 25,000 megawatts yesterday, and so we've already beat all of last year, so we're definitely in a heat wave, and traditionally you can see this is from sort of May to September is traditionally it's Ontario where summer peaking. Okay, that's it for the electricity price data. Bob or Peter, any comments or questions? We do only have 20 minutes, so I think Peter will probably be able to take like one question.
Sure. We had a few clarification questions with regards to market renewal, so I'll just ask one of them now, and this is from Jeff. For market renewal, did you say the peak is no longer key, but the hourly average demand rate?
No, this is very important. So the market renewal is only a change to the hourly Ontario electricity price, the commodity price, the dollar per kilowatt hour price that is now changing from HOEP to Ontario price, or LMP, that locational price. But so yeah, to be very clear, it is not, market renewal is not affecting the global adjustment per se. And so the global adjustment will remain absolutely very important, which is global adjustment is the demand and the peak factor. So yes, very important. The global adjustment is here to stay for the foreseeable future. Okay.
Thank you, Emily. I think we can move on, as you said, in the interest of time.
Okay. So we spoke mostly on electricity, but just briefly, natural gas is much easier. It's way less complex and more predictable than the electricity market, although natural gas prices mainly follow oil. So which oil can be volatile, of course, as we know. But anyways, most charges are highly regulated and subject to approvals and notifications. So that definitely helps. And some large gas users purchase gas via commodity contracts from suppliers outside of the regulated system. So you can have special rates if they can be interrupted for demand response purposes. There's also interruptible electricity rates. So if you're willing to have your natural gas interrupted, aka like cut off for a short period of time, or your electricity, you can definitely make money from that. And if you're able to do that in your operation, then that's something. Not a lot of companies can, of course, but if you can, then you can get some pretty attractive rates there. And so here's some resources from the Ontario Energy Board and Enbridge. And again, it's much easier to model natural gas than electricity. So yeah, we're not going to spend too much time on the natural gas price data, but again, you might want to see Enbridge for forecasted rates for natural gas pricing, for example. There is also the Industrial Gas Users Association, which covers both Ontario and Quebec. And so if you're a member of them, they will also give, I believe they have also pricing data. Certainly if they don't, that could be something you could ask them to do on behalf of the industry. And so now just to wrap up on the that energy budgeting, so analysis and next steps, you want to review the business and operating projections with key stakeholders, identify potential areas for energy optimization, identify timing and expected impacts of planned energy performance improvements. So this is, again, the planned energy improvements performance. So you, again, if you're an energy manager, probably have a register of projects. And so it's important to understand the impact on your energy budget of these planned energy performance improvements or not, right? We had a client who, for example, was building a water treatment plant, and they had not included that in their energy forecasts. And so unfortunately, in addition to all the energy reduction projects that we had identified, we had to add into their sort of base case this extra energy from this water treatment plant that they had not properly accounted for. So then you want to update the model, forecast, and pricing as reflected as required to reflect changing conditions to maintain accuracy. And lastly, before we go to the case study, just a bit on quality control and validation for your budget. So you'll want to have the following key elements. Remember that you want your energy model to be statistically valid with a statistically valid historical baseline equation. So again, at a minimum, if you're doing a regression analysis, you want to have an R-squared of more than 0.75, and you could potentially use some of those more sophisticated statistical techniques such as T-stat, et cetera, RMSE that I talked about. You want to have accurate operating, like production-related and weather data forecasts, accurate forecasting of energy consumption and cost. I would say of all of this, the cost is probably the most challenging, although weather with climate change is, be careful in your weather data that, maybe you want to have a scenario that is looking at some of the IPCC, the International Panel on Climate Change, Intergovernmental Panel on Climate Change. They have various scenarios, and you may want to consider one of them as in your weather forecasts. Accurate estimation of global adjustment performance and resulting cost implications. So this is actually really important for our clients. For some of them, we've modeled out if they hit, so there's 5 peaks, right? So we've modeled out on their energy budget, if they hit 0 peaks, 1, 2, 3, or 5 peaks, what is the financial cost to them? And it's, of course, millions and millions of dollars each year if they hit these peaks or not. And, in one client's case, they're trying to hit 3 out of 5, and sort of a best case is 4 out of 5. And in other cases, like yesterday, I told them, oh, this is almost certainly going to be a peak for the year. And they're like, yeah, we told the executives, we gave them the the data of how many millions they're going to lose, and they said, no, you know, this is quarter end, we need to hit these financial values, and that's their call. Of course, that's the right call for them. But you know, this is really important when we talk about GA performance. It's essentially how many peaks you're going to hit and how that affects your energy budget. Attention to data quality at all stages, you know, checking for missing, misplaced, duplicate entries. Again, negative entries where they shouldn't be. If they're missing, you know, maybe you what is it called, forward fill or backfill, and all those kind of things, and look at anomalies and outliers. And if you have an anomaly or outlier, that's maybe where also you want to get into daily or even hourly, or even in some case, you know, into the seconds. We in some cases will go down to, you know, like the 30-second situation if we're trying to dig deep. Okay, we are on to the case study now. We only have 15 minutes. Maybe I'll have time for one quick question before we dive in, if there are any.
I think, Emily, we can go ahead and just dive in.
Go ahead. Got it. Okay. All right, so let's dive into the case study. So we'll give a bit of general information and background. We're going to talk about the case study follows sort of that same step. So, you know, you want to collect your historical data. Then you're going to develop your energy models using that historical data. Then you're going to produce your energy forecasts, and you're going to also collect the forecasted other data, including business data. And then you're going to use that to enter data and get the outputs to develop your energy budget. So this case study is about an Ontario mine, and they did this energy budget. It is based on real data, but we've changed all the data. It's been anonymized to protect the site's privacy. So none of the numbers were originally real, but we have changed them to just to protect the privacy. So the scope, just like our training today, the scope of the case study is electricity and natural gas. So the energy models were developed using historical, operational, and utility data from 2018 to 2022. A bottom-up approach was used. So the energy models were developed for underground mining and surface operations, aka mainly milling, as well as a comprehensive model for the entire site. And yeah, I'm going to skip that one. Business operational forecasts and energy pricing forecasts were developed for the 2023 to 2030 period. And the energy budget is a crucial part of the overall site energy strategy and formal energy management plan. And I would also say for the whole budget of the site, the operating budget in general. Okay, so just some information on the utilities. So electricity does account for the bulk of the site energy use, and several utility meters as well as many sub-meters covered about 80% of the site's electricity consumption that were all kind of gathered for the energy budget. Natural gas, about 80% of the natural gas used is for direct fired burners for heating the incoming ventilation air in the mine, the underground mine. And utility meters as well as several sub-meters were used for the natural gas. They also do consume small amounts of diesel, propane, and other fuels, but that are less than 10% and used mainly to power some of the mining equipment. Just to note, it is not necessarily very typical to have such a high natural gas use and such a lower diesel use. I would say that typically mines would have significantly higher amounts of diesel. But for the purposes of demonstrating this energy budget, this is all relevant. So no problem is what I'm trying to say. So here's the case study showing, again, anonymized annual production and energy totals. So we have from 2018 to 2022. We have total tons hoisted from the underground mine, total tons milled on surface, the total energy in megawatt hours. We have the site-wide electric consumption. So the total energy would be not just electricity, but also natural gas. The total milling electricity, underground electricity, site-wide natural gas consumption in megawatt hours. So most companies go into gigajoules. In this case, we put into, you can put, the natural gas into megawatt hours if you want as well, and heating degree days. So in terms of data collection, the data was collected, and this would be collected internally from their energy management information system and other business data. So SAP, for example, often companies use that, or as I mentioned, OSI SoftPi or others, and then entered into RETScreen Expert. Data sets included key variables such as daily or monthly tons of ore and waste rock, meters of development, degree days, and the dependent variables were electricity and gas, and they were modeled separately.
Oh, Ali, sorry, just for those of you not familiar with mining terminology, so development is typically tunnels driven underground or ramps that are they're not developed for ore removal. They're for access to different parts of the mine.
Thanks, Bob. So to develop the energy models in electricity, up to 4 production variables were analyzed across different time horizons, and 2 key production variables, tons hoisted and development meters, along with heating degree days. So 3 variables were used for a multivariable regression that produced a baseline equation of 0.73. That's very close to 0.75. We thought that was good, and considering the complexity. And they used a 24-month period. For natural gas, heating degree days produced a baseline equation with an R-squared of 0.98, so very clear and strong correlation over a 36-month period. And we're going to show you these results here. So this is for electricity, and it shows a pretty good fit. The actual here, so this is electricity in megawatt hours, and the time horizon here. So the actual is in gray, and then the model prediction is in green, and you can see that it's pretty good. Nowhere near as good as the natural gas, which we'll show you, but it is a statistically valid model. And then the natural gas here, so natural gas in megawatt hours along the Y, and then the time horizon over the X axis, and again, actual in gray versus green, you can hardly see because it's so much overlapping. So you can see that 0.98 having a really excellent fit between actual and model. So that was historical, right? These were all the historical data and getting the baseline equation. So now we're confident we have a good baseline equation. So we've done the first step, we have a good energy model. Remember, the next step is we need to look at forecasts. So we need to enter the proper forecast data. So we're going to get a production forecast, including tons of ore mill that were derived from the mine plan. And estimates for planned development meters based on other mine plan information. Your energy forecast, the regression equation from the baseline model was extrapolated using production forecast data and normal weather data from Environment Canada. And this was done using RETScreen Expert. So then let's see now what that achieves. So we have here the electricity forecast, consumption forecast. So electricity in megawatt hours on the y-axis and years on the x-axis. So in gray is the actual. So these are the historical values here from 2017 to 2022. And then the model prediction going forward here in green. So that helps us get our consumption forecast, but of course, what does everybody care about? Dollars, not so much megawatt hours. So that leads us to our energy budget. So our energy budget here, this is pretty detailed, and I guess at this point, maybe Peter, if you haven't already, would be a good time to put in the chat. We do have this case study, the same case study, but in more detail in a PDF on the ISO Save on Energy training website. So perhaps Peter, when you have a minute, if you could just put that in the chat, and then people can download that case study. And so I'm not going to go through all the details here just due to time, but essentially we get the Ontario price, the commodity price, then we look at the global adjustment and we calculate the global adjustment, and then we add in the other electricity charges, and then we total all of those, and that'll give you your energy budget in dollars here. And then often in energy budgets, you also want to have a dollar per megawatt hour. So if your planned megawatt hours changes, then you have that value here as well. And if we have time later, we can take some questions on building up this budget, but I would encourage you to go through the math. It is, we hope we tried to make it pretty straightforward. So for example, here we say, you know, row 1 times row 2, so you can kind of figure out how to do this. And I would, you know, if you have never developed an energy budget, and certainly if you're based in Ontario, this is an excellent map. If you're not based in Ontario, I would just replace global adjustment with your demand charge, but it would be potentially calculated differently, slightly from this. And yeah, to kind of get to the end here, so a summary of the purpose of energy modeling and budgeting. Building up a bottom-up energy budget from an energy model helps organizations gain a deeper understanding of your facilities, process energy use, and I would say building energy use and associated costs under various conditions. It's the energy budget is a key element of the management planning and reporting. And just a reminder, you know, your actual energy consumption and costs should be measured against the budget on a monthly basis at a minimum, and then followed by timely management reviews, corrective actions, and revisions. So that leads to the end of the key portion. We do want to sort of open it up for sharing of project experiences. We don't have a lot of time, I would say. So if there was anyone, I guess, just before we wrap up, who had a key comment, probably literally only have time for maybe one sharing at this point, but we have shared a lot of questions, I think, and we will have more, I think. Well, I can't promise anything, but we're hoping we might have a follow-up session at some point on this, because there's certainly a lot of interest and a lot of content. Peter, I'll turn it over to you to, I guess, manage if you'd like anyone to share, or if I should just go into wrap up.
Yeah, if anyone, we have time for perhaps one additional question or experience sharing from the audience, from the attendees. And if not, I can ask one question on behalf of the audience. So Mohammed asks if there's a budgeting template that can be shared. And I think the short answer is that was not intended to be part of the presentation, but perhaps, you know, we can provide some direction as to where they can find that.
Yeah, and I mean, maybe that's a consideration for a future session, potentially, to provide that budgeting template. Yeah, I would suggest, again, if you
I see Asia had her hand up.
Oh yeah, go ahead, Asia.
Oh, hi, thanks. Really enjoyed the presentation. So much good information, and just around things like budgeting templates and stuff like that. That's part of the support in the EEM program as well. Just wanted to bring that back. If you're looking for some cohort and coaching support on that, that's one avenue to go through.
Excellent point, Asia. I had forgotten about that for sure. That's a really, really good point. Thank you.
And that information will be in the slide deck that we'll send in the coming days.
Perfect. Okay, I know we could probably go on for at least another half hour, but I think we'll move to the wrap up then, and it's good to see a lot of interaction. Okay, so just there's a few additional resources here on the Energy Performance Program, the IPMVP, and the ISO 50001, and you can look at the training and support webpage. And yeah, thank you very, very much. I guess we had one more. Bob, did you want to say we have one more minute to last wrapping up thoughts, or?
No, it's all right. That's
okay. I think that's it, Peter. So I'll turn it over to you if, yeah.
Great. Well, thank you so much, Emily and Bob, for this super useful and really interesting training on how to create an energy budget. And thanks also to Asia for providing an update on Sayona energy programs. And thanks most importantly to you, the audience, the attendees, for your time today. Keep an eye out for this presentation in the coming days, which we'll be sending you together with a link to a survey for feedback on the session. And we look forward to seeing you at future Save on Energy training events. Thanks again, and have a good rest of the day.
Thank you.
Thank you.
Thanks all.